My name is Joseph. End of semester course project presentation. My topic is business requirement document for machine learning model. The model is developed for an insurance company, Ken La Hacienda Insurance Company. Course project introduction. I'll be talking about company background and the need for the model, the development of the model and the model requirement, functions and objectives of the model methodology, timelines, project scope, model use cases, the use case scenarios, process diagram, data flow, data modeling, sequence diagram. I'll also be talking about the time period for the development of the project, which is in 4 phases. I will be talking about team formation and a project purpose. Also the budget for the project, risks associated to the project. We have the software risks, hardware risks, human risks, and I'll be discussing the user story and do some project evaluations. La Hacienda Insurance Company was formed in 1999 and is based in Kumasi, the second largest city in Ghana. The company deals in auto and health insurance. The company has widened its market to include life and long-term disability coverage. Due to this expansion, the insurance company is advocating for a new machine or a new model that can help predict the likelihood that a customer will buy an insurance policy. This is important because amid the coronavirus, customers are unable to visit the premises, and so the company is reducing in terms of customer capacity or customer base. The machine model will generate and issue code to likelihood customers or customers who are likely to buy the insurance policy. Business requirement document. So this business requirement document are documents that will be needed for the development of the project. We have the functional requirements, which includes documents that will tell how the system will predict and issue code to customers, and also how the system will be able to track potential customers and keep customer information. The other requirement that is needed is the technical requirement. The technical requirement pertains to the technical aspect of the system or what the system must fulfill. It could also be thought of as the requirements or the qualities, attributes of the system. So we have scalability, capacity, availability, and reliability to be the technical requirement. We are now going to the project scope. So in the project scope, we have the engineering team will be led by the project manager, and they will be creating the model within 4 weeks. Every project has a criteria for acceptance. So this model must be able to generate accurate predictions and then help reduce processing time. And then the main goal is to generate revenue and also acquire customers or to build a bigger customer base. And then the last project scope will consider deliverables. So accurate predictive components will be delivered. and the system, the project will deliver the development in phases, and the development must be able to meet the client requirement. It should be able to automatically initiate codes to customers and also have the ability to keep data. Project timeline. So when you look at the project timeline, this project takes effect from July 15th, 2020 to August 15th, 2020. It's a 1 month, a 4 weeks, that's 1 month project. And then some, because of the methodology used, some of the periods interlaps a little bit or overlaps a little bit. So when you look at the phase 1, where at the beginning or the first day, the project manager forms the teams, they meet and they form teams, and then the project manager, the following day, the project manager allocates resources and also assign responsibilities, and then the technical requirements are taken. Then we move on to phase 2, where development starts. So you realize that within the last part of phase 1, phase 2 starts. So over there's a little bit overlap, which to me it makes sense, because you don't have to finish everything. Even if it is on the 14th that they are finishing the phase 1, on the 14th there's time, the phase 2 can be started. So that is how I projected my timelines. And then when you come to phase 3 has a little bit of overlap with phase 2 at some point. We know that the agile or the Scrum methodology accept changes, and so the changes, and then they also can revisit. It is subject to change and it can be revisited at any time. So that's why I kind of designed the timeline this way. And so you realize that we have reviews and testing in phase 3, and then we have implementation also in phase 3. So implementation definitely goes with some form of testing, and that is why phase 4, that is basically assigned for testing, is also being seen to have had a little time overlap with the phase 3. Then the phase 4 has a very long time, because it involves the final testing, and then it also involves training and workshops, and it involves the final handing over. So you realize that on the 14th the workshops end, and then on the 15th there's a handover, then the project ends. So this is the model usage. So the model is written to describe how the task will be performed on the website or on the company website, and then so the use case, the model should be able to predict potential customers. Now we have the preconditions. So with the preconditions, that is where the data is being processed by the model, and then the post condition is at the end of the entire process, what happens. So this is where customer information is kept or is saved for future transactions or for future use. We also have actors involved in this model, the model use. We have the primary actor, or the primary actors, and the secondary actors. So the primary actors are going to be the customers, and then the secondary actors are going to be the insurance agent or the company. Then we have stakeholders, that includes the insurance company. The goal is to have a model that predicts customers who are likely to accept insurance terms. And the basic flow is going to be the insurance data or customer data being identified through some parameters, and then the model creates a list of predictions, and at the end of the day, the data is kept. And then we have an alternative flow. This alternative flow is in case there's an error or there's incorrect information entered by customers, the system actually is unable to process the information, so it's unable to generate a policy for the company. So this is rejected. Now we have a use case scenario here where we have the insurance model and the model which is being barricaded by a border. So this borderline tells that anything within the insurance model is part of the machine, and anything outside the model are external actors. So we have the customer being the primary actor, and then we have the insurance agent being the secondary actor. So basically the primary actor acts or initiate processes, and then the secondary actor reacts to the processes. So the customer calls in for a quote, the insurance agent processes the customer information, and then finally the policy is sold to the secondary, the primary actor. We have a user story, which is very important in the Agile framework, and we know Scrum is an Agile framework. So these are basically the descriptions of what we expect the model should do. And normally the user stories are developed in the perspective of the customer. So the listed 6 user stories are for the functionalities of the model, where one example is, as a shopper, I want simple shopping cart functionality so that I can shop for quotes easily online. Another one is, as a shopper, I want to see all quotes between $20 and $75 monthly so that I can choose my desired policy. The rest are as shown on the PowerPoint. We have a business process model where the customer initiates, or the customer starts the process, and in parallel with the representative's actions. So from the start to the end, what happens between the customer and then the representatives are shown here. So customer calls in, insurance agent processes, and at the end of the day, a data is kept. So when you look at the middle side, you see DBMS, that is where the database is. So at the end of the day, processing the information, the data must be kept for future reference. We have a class diagram here that shows different classes and how they function. So we have the customer entity, we have the artificial intelligence, which is the AI model, and then we have the policy. So each of them has attributes with data formats, and then we also have a function key, what the entity will be doing. And so if you look at the customer, we have the entity will set a name as a function, and it will also request for code, and then the AI will generate code, transfer code, and integrate code. And then the policy, that is where they process the policy. So each of them has its own functionality. We have the relationship between them, between the customer and then the AI association, and then between the AI and the policy is composition. So with the composition, it means that without the model, the policy will not exist, because the model is what mediates the policy and then the customer. On the other hand, the customer can exist independently, and then the artificial intelligence can also exist independently from the customer. we have a sequence diagram where the actor, which is the customer, interact with the system sequentially. And we have an alternative here. If the system is unable to process the customer information, or if the customer gives in a wrong information, the system rejects it back. We have a data model here where we have the customer information, we have the artificial model information, the artificial intelligence model information, and we have the policy information. So basically, this gives you the primary keys and then the second the foreign key. So you see that each of them has a primary key. However, the artificial intelligence model has the policy ID or the policy number, and then the customer ID as their foreign keys, because it is the central model that links between the policy and the customer. Data flow. This is how the data is going to flow. It flows from the customer's perspective to and then the customer provides data to the agent processes the data is kept in the database, and then it is being sent to the model for prediction. The model does its prediction, and then it is sent back to the agent, and then the agent now issues the process to the customer. So we evaluate the project. Every project needs project evaluation. So here we talk of maintainability. So these are actually challenges, constraints that normally bottleneck the project, and so it has to be evaluated. Here we are trying to make sure that there's data availability at all time, and the system has the ability to automate backups. In case there's a database failure, there should be regular update and testing against bugs and malware. Scalability. The system must be designed with the capacity to grow, so that if it happens that there's new updates or new implementations, the system will not be vulnerable. We also have vulnerabilities and securities, where we have physical and technical security. The physical security includes locking of doors, and then making sure the premises is not prone to any natural disaster like hurricanes. We have the technical aspect, where we have to protect the system by teaching employees to employ stronger password. Then we have legal issues. So the system must, the developers must abide by intellectual property, and there's always a contract in agile methodology or the Scrum, because the development is in sprint, and each sprint must be respected. Each sprint time must be respected and must have an end goal. Sprint considers collaboration between leaders, teams, and then the client. Each sprint must be completed, and the entire project must be completed without termination. Once the project begins, it must not be terminated. Thank you so much. These are my references.